you'll hear everyone and their mom talking about mutation in terms of COVID, right? And that's because viruses replicate the fastest of any biological entity. When you replicate, you mutate. So viruses mutate even within one cell, can give rise to many different variants, and even different variants and little variations can be present in one person with an infection. So obviously mutating and getting different variants isn't enough to select for these prevalent strains, the top 5 that we care about, particularly Delta now. And so what explains, the selection pressure that we now have the Delta variant? And so what I posit is that, well, actually, first I'll ask you, Rob, do you know what the difference between the Delta variant and the COVID Alpha or the original COVID is?
Oh, geez. No.
Oh, hell yeah. Well, we're going to learn today. So this is really interesting, and you're going to love this. It's called the Delta variant because the Delta variant has 5 amino acid substitutions in its spike protein. So this is the same spike protein that we're getting vaccinated against. And this is important. So the spike protein is about 1,200 amino acids, and we get the mRNA in a little viral-like particle, basically injected into our muscles. There, the mRNA goes inside cells and produces that original COVID alpha spike protein, with the idea that our body will then create antibodies against that original COVID spike protein. Well, this provides people that have not been involved with COVID before, but have gotten the vax, with a high titer of very specific antibodies against that original COVID spike protein. And of course, now we're learning more and more about breakthrough infections in Delta. And as I mentioned, the difference between the Delta variant and the original COVID, the only difference is 5 amino acid changes on its spike protein. And this is important because even changing 1 amino acid is all you need to throw off antibodies to change their effectiveness, or to change the antibodies to maybe do something else for the virus.
So just to, build off of that and kind of put into simple terms, right. The mRNA vaccine is, and it doesn't take a lot of science to understand this.
Right.
Essentially, it's to combat one thing, and that's the original virus. And we know that viruses change. We know that. And so we're injecting something into people that we know that after a single mutation won't work, because by design, it's not giving you robust immunity. Maybe that's not the proper medical way of saying this, or it's not giving your body the ability to boost
outlast the virus.
Yeah, its general defenses, or learn how the thing works and then be able to beat it. It's giving you the tool to defend one very specific version of the virus. It's almost like, if I learned how to, this is fucking stupid talk.
Yeah.
Let's say there was a tiger in armor, and the one place it didn't have armor was by its neck, and I'm playing this video game, and I learn, okay, I got to stab it in the neck. Right. And then all of a sudden it comes back, and now it's got a protective coating against the neck. Okay, so I had one tool to beat this thing, and that one tool doesn't work. That's basically what the mRNA is. It's giving you one single tool which works against one single virus. And we know that the thing mutates. We understand that viruses mutate. So it's highly predictable that as there are mutations, this is that the new, like, in other words, it's not going to work against the mutations because it's not designed to. It's not what it is.
Can I add a little bit more to that? Because like, you totally get it, Rob, but like, I don't think you get it, man. Because let me explain. It's more insidious than what you think. So there are various families of viruses, and coronaviruses, which contributes to the common cold, as well as SARS was a big deal some years ago. It's very well known that coronaviruses routinely change their spike protein, and specifically the spike protein. And this is just because you can think of a virus as a basketball with goo on the outside and with nails sticking out of it, right? And those nails are the spike protein that help the virus kind of find the cells it wants and to get inside them and infect, right? And so it makes sense that if you wanted to vaccinate people and create a way to stop this first virus quickly, you would target those little nails on that gooey basketball. But like you just mentioned, and as all the literature points out, like, everyone and their mom knows coronaviruses that are called coronaviruses because they have cool spike proteins that look like crowns. So crown, coronaviruses. And so everyone knows that all a virus has to do is change that little outside spike or just a little part of it, and then the antibodies won't work. Right.
Okay. And now just in terms of speaking maybe to the more insidious nature of this, so the companies who are selling this would know that this is not like advanced science or something that they couldn't see coming.
Right.
So just two-part question there. First one is, could they have designed this in a way that it would be able to combat variants, or does that technology not exist?
That's very interesting. And so now we can compare and contrast with other vaccines. So routinely, depending on the virus, one would originally might grow the virus that you want to vaccinate against in the lab, and then actually use formaldehyde, the same chemical that you use on dead bodies, to stiffen them. And that's because formaldehyde actually chemically links various residues together, and doing so, it inactivates the virus. But the beauty of giving someone an inactive full virus, including maybe some of its genetic material in their body, is that your immune Pac-Man cells come by, chew it up, and then you start making antibodies to all different parts of that whole virus that you got injected to. So now your immune system is armed with not just antibodies against the spike protein, but also what's called the N protein. It's a nucleocapsid protein that's inside the virus, or maybe even the capsid protein. So yeah.
Okay, and then just maybe this is a dumb question, and I've never been clear on exactly the relationship between shed rate and transmission. So I've heard at some points in time they were trying to say the reason why this thing is so deadly is because people cannot know that they're sick and actually be infecting other people. And then I've heard if you're not coughing, you're not like it's a function of shed rate. Why couldn't you have a traditional vaccine here? Because I've also heard that you might get less sick depending on how much of a viral load you're infected with. So why is a traditional vaccine not possible here to give someone, a very low viral load, or almost like a more sterile viral load, so that they could actually I mean, obviously that can't be done because it seems so simple and they're not doing it. So why does that not work with coronaviruses?
No, I mean, that's a great point. I think previously, and I'm going to answer your question right now, I don't know the specifics, but I'll certainly be sure to look that up and communicate with you further. But in my opinion, in the past, what's happened with the risk reward and even just the development and the trials for a vaccine against the common cold wasn't really there or worth it. And like I mentioned, coronavirus is actually, because if you imagine that basketball that's gooey with the spike proteins, sometimes it's hard, even if you get antibodies against stuff that's inside the virus, for those antibodies to be particularly effective because they're targeting stuff inside the virus. And this really comes down to kind of a family virus by virus situation. But again, to answer your question, I don't know. And that's what really concerned me. And that was the first reason, man. The second they jumped to mRNA technology, that perked my ears up. That's like, this is literally what I do in the lab to create viruses, right? The only difference is we're only giving the spike protein, right? So I'm actively transfecting in various DNA or RNA into cells in the lab, and I'm thinking there's no way they can use this for a vaccine when there are easier routes to take first.
Okay, so handing it back to you. So now that we've established that we know that there will be variants because viruses do mutate, I think you had a second point on this side.
Right. And
just to go back, I think you might have missed your point that I just see that you might want to state the hypothesis.
Oh, right. Yeah. And so just to summarize, so my hypothesis is that by pumping people with a vaccine specific for the original COVID spike protein, that nail on the outside of the basketball, it's putting the natural selection pressure as part of the viral evolution as described up here that will then help select for the Delta variant. So I'm sure we've all...
Wait,
right.
But what's really scary about that, and you can correct me if I'm wrong here, but if, let's just say, for example, there actually was a mutation that was deadlier, right? Mm-hmm. And we gave people the ability to protect from the first one, so now they're more likely to get infected by the second one. Now, what's wrong about that analysis, and maybe you can correct me if I'm wrong, but from what I understand, generally speaking, mutations do not become deadlier. But I guess if we fuck with Mother Nature, where we're changing the way that viruses, basically the way the life cycle of the virus, if we're changing it because now we're like very specifically just protecting against one version, it's almost like the gym for the virus. We're forcing the thing to mutate. Yeah.
You are so exactly right. And that's the only reason I started. Sorry, I got a little technical with the amino acids and stuff, but that's the only reason I brought it up here, because that's such an important point. I hope you can keep driving in. It's just levels of insidiousness that, mutations happen, right? I don't care what virus. If a virus is replicating, it's infectious. If you're shedding, it's mutating. There's no if, and, or buts. You only need one virus to replicate in one cell, and you already got mutations. So these variants that we're seeing, it's not a function of mutations. Mutations happen all the time. They're a function of the natural selection pressure that we artificially are putting on this virus. Like you said, we're sending the virus for a workout by saying, hey, look at all these vaccinated people that don't like that one original COVID spike. So I dare you to come up with a new one.
Okay, I'm on board.
Yeah, so it's really interesting, and again, I don't want to spend too much time. This slide is just kind of re-emphasizing what we just talked about, and this actually does explain the difference between the Delta variant, and it's not a coincidence that the Delta variant has the amino acid changes only in its spike protein. Besides that, it's the similar, right? So that's just really interesting, right? And so now just kind of the last part, I did want to get to this just because I think it's relevant too, to kind of change gears, because we're going to talk about the vaccine trials, and we're going to talk about kind of building on what you guys have talked about, the absolute relative risk, or absolute risk reduction versus relative risk reduction. Is that okay?
Yeah, no, please. This is something that's I haven't totally, I understand it, but it seems so crazy that it's an argument I almost don't want to present to people, because I feel like I must have this wrong. Because when you start equating the personal boost that you might be getting from taking this, it basically does not exist. So I'll hand it back over to you, and then I'll kind of put it into simple terms and maybe ask my questions of why I'm not 100% on it. But I think that this is, every time I've read an article about this, I was like, this must be not true conspiracy talk, because it just seems so unbelievably flagrant in terms of a marketing way of presenting how much help you would be getting from this.
That's